Good day and welcome to AFD'S Academy. I am Arthur Francis Devan. Today we're going to be dealing with qualitative analysis, which is principally the test for cations and anions. But today we're going to focus on cations. Now, what are cations? Cations are positively charged ions. For example, we have calcium 2+, is a cation. We have magnesium 2+, we have aluminum 3+, and so on. All these are cations because they are positively charged. Now, for us to be able to determine the presence of these cations in a particular salt sample, we have two basic reagents which we can use, that of sodium hydroxide and ammonia, or aqueous ammonia, which is ammonia in water. So for that to be done, we will be able to check religiously or stepwise the various observations, the test observations, and the inference when we use particular or peculiar cations. Definitely, it means that when a sample of salt is given to you to analyze in the lab using sodium hydroxide as your reagent, you'll be able to determine which of the charges or ions that are present. Is it out of calcium? Is it aluminum? Is it zinc? Is it copper, iron, and so on and so forth? We'll be able to check that out. Let's look, for example, let me give us a spectrum of what we're going to be dealing with. Calcium 2+, copper 2+, zinc 2+, aluminum 3+, lead 2+, ammonia from ammonium, let's call it NH4+. I think these are basic. Now, in the laboratory, you'll be given a sample of salt, let's call it zinc chloride, or calcium chloride, or sodium chloride. You are meant to determine the cation present. So, a little proportion of that salt will be taken into your test tube. You add a little water to make it in aqueous form. Sometimes it will be soluble, so you have to ensure you enhance the solubility by shaking it to dissolve. Now, when you introduce your sodium hydroxide, there will be a reaction. The sodium hydroxide targets the cation, which means it reacts with the cations, and it will give you a peculiar color. That color should be able to define which of the salt or which of the cations are present in the salt, because the salt has been given to you and labeled sample A. You don't know what that is. But if it is copper, first you have to look at the physical appearance. What is the physical appearance of that salt? If it is blue, at least you can begin to have an idea that blue is for copper. If it is brownish, it is ion 3. Green is ion 2. White, it is either zinc, lead, aluminum. But then, be that as it may, some of them are not soluble. So sodium hydroxide will be able to tell us if it is actually zinc or aluminum or whatever based on the reaction. So let's take example. We have our test, the manner in which it's going to appear to us. We have our test, we have our observation, and we have our inference. So let's say if we are testing for zinc 2+, and this is what we are looking for, but it is given to us as sample A, and that sample A could be zinc chloride, all right? So we don't know what that is, but this is, the instructor knows that it is zinc chloride, it is in the sample, or zinc sulfate, or whatever it is, but he calls it sample A. You do not know that this is there. The first thing you're going to do in this place, this is what we are going to look for. So you are going to have the sample, which is A, sample A plus a little distilled water. When you do that, the next thing you do, you make it dissolve. You add a few drops of sodium hydroxide to this. If you add sample A plus sodium hydroxide in drops, sodium hydroxide in drops, and SS. That's how it is. Now, if it is zinc, we're going to get observation. We have a white gelatinous precipitate. I'm not going to be writing, but you should just pay attention. We're going to get a white gelatinous precipitate, which is insoluble in drops, but soluble in excess sodium hydroxide. So, which means that test tube of yours containing that salt, when you add your sodium hydroxide in dropwise, you're observing, nothing happens. Then you add that sodium hydroxide in excess. The white gelatinous precipitate will dissolve in excess of this sodium hydroxide solution. That is it. And you will now say, inference, you have zinc 2 plus present. If it is lead, if you are dealing with lead, if it is lead that is present, we're also going to get this white gelatinous precipitate in drops, which is soluble in excess of sodium hydroxide. Zinc, lead, and aluminium exude the same properties. So which means zinc, lead, aluminium, when you react them with sodium hydroxide, they're going to give us a white gelatinous precipitate in drops, which is soluble in excess of sodium hydroxide. So the inference in that case will always be zinc, or lead or aluminium present. Now, what if we deal with copper? If the sample is, for example, copper sulfate, let's say this is it. Copper sulfate, you do not know, and we call this sample A, and you are asked to put it in the test tube and add your sodium hydroxide, which obviously will attack the cation, which is the copper. What are we going to get? A blue or light blue gelatinous precipitate in drops, which is insoluble in excess of sodium hydroxide. So copper is not soluble. But how will you know that this sample is copper? First is the color, which is the light blue gelatinous precipitate. If it is iron 2 plus, we have also iron 3 plus. If it is iron 2 plus, it gives us a light green gelatinous precipitate, which is insoluble in drops and excess of sodium hydroxide. So this guy is not soluble. Iron 3 will give us reddish brown gelatinous precipitate, which is insoluble in drops and excess of sodium hydroxide. So by virtue of that, we will know that once I see brownish solution, my mind goes straight to iron 3. I see a light green, it goes straight to iron 2. Light blue goes straight to copper 2. White, things that come to mind will be lead, aluminium, and zinc. These three are soluble. But calcium gives us a dirty white precipitate. If it is calcium, it gives us a dirty white precipitate, which is insoluble in drops and excess of sodium hydroxide. Insofar that I know that zinc, aluminium, and lead will be soluble, but calcium is not. Calcium is insoluble. The white is dirty white, which is insoluble in drops and excess of sodium hydroxide. Iron 2 is green, copper is blue, iron 3 is reddish brown. What if we are testing for ammonia? Ammonia will give us NH3+, so it is cation. So let's say the salt is ammonium chloride, NH4Cl. Ammonium chloride. And when I dissolve this in water, it will dissociate to give me my NH4+ and chlorine negative. So this will react with sodium hydroxide. But in a sample that contains this, first, when we add sodium hydroxide, there is no reaction. But on heating, when you add it, there is no reaction, we have to heat it. On heating, a gas, a colorless gas with pungent smell is given up, comes out, which turns red litmus paper blue. Acid turns blue litmus paper red. But the gas turns a red litmus paper blue, which means it's alkaline gas. And the only alkaline gas we have is ammonia. Alright, it is the only alkaline gas. The rest, it doesn't have any other. So any other gas you see is not alkaline, it's acidic. But this is the only gas that turns red litmus paper blue. And this same sample, when we add concentrated hydrochloric acid, it gives us dense white fumes will emanate. which shows that that substance is ammonia. If you react ammonia with corn you get that dense right, so that's what they're trying to tell us. We are going to see that practically, or maybe I'm going to have a practical life class where, as I'm saying it, I show you how it is done. So that when you peradventure you encounter with such challenges, you will know exactly what to do. And now, like I said, we have our test for, we use sodium hydroxide, and we also use ammonia solution. But this ammonia solution, many times, we use it as a confirmatory test, all right, to confirm what we have said. Because if you give us white precipitate with sodium hydroxide, what will it give us when we use ammonia solution? It could be different, it could be the same sometimes, but whatever it is, we'll be able to confirm that which we have done with sodium hydroxide using ammonia solution to know or be certain that this is what it is. So let's take a look at that with ammonia solution. Okay, now the first one we dealt with was with sodium hydroxide, but with ammonia. When we react zinc salt with ammonia solution, we are going to get a white gelatinous precipitate which is soluble in excess of ammonia solution. We can say zinc 2+, confirmed. Why am I confirming it? Because when I know too well that zinc is soluble in sodium hydroxide and it is also soluble in ammonia solution. So if I use it with sodium hydroxide and still use it with ammonia, and with the ammonia it is soluble, then I can confirm it that it is zinc. But lead and aluminium will give us white gelatinous precipitate in drops, which is insoluble in excess ammonia solution. You see the difference? When we use sodium hydroxide, zinc, lead, and aluminium were soluble. But when we react these three same cation ions with ammonia solution, only zinc is soluble. So I'll be able to confirm with ammonia solution that if zinc is present, it will be soluble, and I confirmed it. If it is lead, which I have a white gelatinous precipitate, all right, which is soluble in excess of sodium hydroxide, but now since I know zinc, aluminum, and lead are soluble with sodium hydroxide, I do not know if these same guys will be what the reaction will become. So I have to use ammonia solution. If it is soluble, I will say it is zinc. If it is insoluble, I can confirm that it is either lead or aluminum present. Now, we look at calcium. There is no reaction. When you use a calcium salt reacting with ammonia solution, there is no visible reaction. That is it. And calcium with sodium hydroxide, there was a reaction actually, but it was a dirty white precipitate which was insoluble in drops and excess of sodium hydroxide. Now, which one again? Copper. In copper, when we use copper with ammonia solution, we get a blue precipitate in drops, which dissolves in excess ammonia solution to form a deep blue solution. Remember that copper was not soluble with sodium hydroxide. It gave us a light blue gelatinous precipitate in drops, which was insoluble in excess of sodium hydroxide. But with ammonia solution, that blue precipitate dissolved in excess to form a deep blue solution. Then we can confirm that it is copper 2+ present. Ion 2 will still give us a light green gelatinous precipitate with what? Ammonia solution, which is still insoluble, and ion 3 still the reddish brown precipitate, which is insoluble. So, like we've seen, I've been able to give us a comparative analogy of the cationic test using sodium hydroxide and ammonia solution, and told us religiously that calcium with sodium hydroxide gives us dirty white gelatinous precipitate in drops, which is insoluble in excess of sodium hydroxide. Copper gives us light blue gelatinous precipitate in drops, which is insoluble in excess of sodium hydroxide. Lead, aluminium, and zinc give us white gelatinous precipitate in drops, which is soluble in excess of ammonia solution. Ion 2 is light green gelatinous precipitate in drops, which is insoluble in an ammonia solution in sodium hydroxide. And ion 3 give us what reddish brown. Sometimes we call it reddish brown or brownish what gelatinous precipitate, which is insoluble in excess of sodium hydroxide. But that's those same reaction when we try them with ammonia solution. We realize that zinc that was soluble, aluminium and lead that were soluble with sodium hydroxide are no longer soluble with ammonia except for zinc only. Aluminium and lead are insoluble in excess of ammonia solution, but zinc is the only gas that is soluble in both sodium hydroxide and ammonia solution. And copper, which is light blue gelatinous precipitate in drops, which was insoluble using sodium hydroxide, becomes what? Soluble to give us a deep blue solution when we use ammonia solution. And we also said about iron 2 and iron 3, these two guys are insoluble in both reactions. They are insoluble. And calcium, there is no visible reaction with ammonia, but there was a dirty white precipitate with what? Sodium hydroxide. And finally, ammonia, to test ammonium salt, which is probably ammonium chloride. We said there was no reaction with sodium hydroxide, but on heating, a gas is given off which turns red litmus paper blue and give us and contains pungent smell. And we say that gas is ammonia. We can still test that using what corn HCl, which give us dense white fumes with concentrated hydrochloric acid. So these are the basic preliminaries of cap ionic test, which we will obviously carry out in the laboratory, but our understanding of the color which they exude and the reactions in sodium hydroxide ammonia are very essential, because when you have been encountered or confronted with the challenge of carrying out the experiment without anybody guiding you, what you see defines what your inference should be. And everything is based on physical observation. What do you observe? Is it blue? Your mind should go to copper. Is it green? Iron. Is it brown? Iron 3. Green, iron 2. White, calcium, of course, is dirty. While aluminum, zinc, and lead are white in color. So your mind goes there. It takes you a step closer to where the answer is. And from there, based on the drops and S's, you'll be able to conclude religiously that it is either zinc or aluminium or lead or whatever the cation may be. So this is just the basic preliminary. In our next class, we're going to be moving into the real practical class and also the anionic test, which are the anions. So do have a wonderful time. It was a pleasure being with you again after a pretty long time. I look forward to see you again when I see you. Thank you.